Greetings, everyone. Hydrogen is the latest buzzword when it comes to dealing with energy issues, especially climate change. There is now increasing realization that in order to meet the Paris target of limiting temperature rise to 1.5 degrees Celsius, one will have to shift the focus to more difficult options like hydrogen. When we say hydrogen, we mean green hydrogen, which is derived through electrolysis of water using renewable sources like solar, wind, and biomass for generating electricity. Today, less than 1% of the world's hydrogen is green. Hydrogen is a key component of our new energy roadmap, India's former oil minister Dharmendra Pradhan had said in July this year. Together with ethanol, the government is clearly looking at alternate fuel options beyond its focus on electric vehicles. Ladies and gentlemen, it is with great pleasure that the Center for Auto Policy and Research, along with Mobility Outlook, presents to you a series of dialogues on alternate fuel options for the country. And today, our focus is on hydrogen. To learn more about the subject and to take a detailed view on hydrogen, we are indeed honored to have with us three distinguished domain experts. It is indeed my special privilege and honor to welcome Dr. S A Sherif. He is a professor of Mechanical and Aerospace Engineering at the University of Florida. He is a Life Fellow of ASME, a Life Fellow of ASHRAE, a Fellow of the Royal Aeronautical Society, an Associate Fellow of AIAA, Vice President of Commission B2 on Refrigerating Equipment of the International Institute of Refrigeration, a member of the Advisory Board of Directors of the International Association for Hydrogen Energy, and a founding member of the Board of Directors of the American Society of Thermal Fluids Engineers. Dr. Sherif also serves as the editor-in-chief of the ASME Journal of Solar and Energy Engineering. He has also served as editor-in-chief of the ASME Journal of Thermal Science and Engineering Applications between 2014 and 2019. He's on the editorial boards of 30 other thermal science journals and has 300 refereed papers, one book, 20 bound volumes, 24 book chapters, 190 technical reports, and 2 US patents. We also have with us Mr. Suresh Arikapudi. He's the General Manager, Advanced Technology, Tata Motors Engineering Research Center at Pimpri in Pune. Mr. Arikapudi has 22 plus years of experience in the automotive industry, working on advanced engineering activities for the past 17 years, especially on system engineering and integration, hybrid powertrain systems, electrical vehicle powertrain systems, fuel cell systems, and stack development, advanced mobility controls, and virtual validation of advanced powertrain systems. At present, he is responsible for delivering passenger car, electric vehicle powertrain, and fuel cell systems. We would shortly be joined by Dr. Lalit Mohan Das, a former professor of IIT Delhi. Dr. Das's teaching and research career span over 44 years, especially on alternate low emission fuels such as hydrogen, biodiesel, CNG, HCNG, propane, ethyl alcohol, etc., used for internal combustion engines for automotive and non-automotive applications. Dr. Das has been the director of a UNIDO-funded consultancy project on hydrogen, operated three-wheelers in India. He has been a member of the advisory board of the International Association of Hydrogen Energy. Gentlemen, welcome to this session on hydrogen. And I will now start off by requesting Dr. Sherif. Okay, we can see Dr. Das has just joined us. Dr. Das, welcome to the session. So Dr. Sherif, I would now like to invite you over for your initial comments and initial thoughts on the subject. You may please share your screen now. Thank you.
So good afternoon, everybody. I hope everybody can hear me okay. It is my distinct pleasure to be here with all of you, and thank you very much for the very kind invitation. I thank also Professor Das. He and I have known each other for a long time. It's my pleasure to see him again. What I would like to do is give you a very brief status report on where hydrogen is here in the United States, and then have a little bit of a twist on vehicles at the very end. So this is going to be again brief, just to stimulate some of our thoughts. The hydrogen energy system essentially is a global energy system in which electricity and hydrogen are produced from available energy sources and then used in every application where fossil fuels are currently being used. In a system like what we call the hydrogen energy system, basically electricity and hydrogen are going to be produced in large industrial plants, as well as in small decentralized units, whatever the primary energy source, such as solar energy, wind energy, nuclear energy, or fossil fuels are available. Of course, clean hydrogen or green hydrogen is where you would use solar or wind as alternative energy sources to produce hydrogen. Hydrogen is considered to be an energy carrier, not an energy source, and that's an important point to make. This is what essentially a hydrogen energy system looks like. You produce electricity, you transport electricity from the source to the final destination, and you can also use electricity to electrolyze water to produce hydrogen, and then you can transfer hydrogen in pipelines and use it for all kinds of applications, chemical, industrial, domestic, and so forth. You can also use it for transportation, especially when you are using either compressed hydrogen or liquefied hydrogen in cars and vehicles. In the United States, actually, I am very pleasantly surprised in some ways over the past couple of years to see this big, huge push in towards hydrogen. This week happens to be what we call Hydrogen and Fuel Cell Week, which is October 4th through 8th, 2021. So we are in it, in the middle of it. They actually selected October 8th to be a very special day, because October 8th, October is the 10th month, and 8 that would give you 1.008, which is the atomic weight of hydrogen. So 1008 is the date, and 1.008 is the atomic weight of hydrogen. They have selected that to be the Hydrogen and Fuel Cell Day. That's sort of symbolic to celebrate hydrogen and to identify and highlight the role that it plays. So this is good, because this is led by the U.S. Department of Energy, and there is a big move in the U.S. Department of Energy to make hydrogen very important. In fact, I'll give you some small statistics here that would go along with what my point is that we have 10 million metric tons of hydrogen annually that's being produced in the U.S. We have 170 megawatt of electrolyzer capacity. This is being used to produce hydrogen from water. 45,000 hydrogen-powered forklifts in warehouses and supermarkets, and thousands of fuel cell backup power units that have hydrogen to provide electricity during blackouts. So this is all the good part. The not so good part is that it's still a little too expensive to produce hydrogen. So we're going to talk about that in a little bit, and I'll tell you what the target is for the U.S. Department of Energy. They also have established a Hydrogen and Fuel Cell Technologies Office, which is a new office that has been established recently. And this Hydrogen and Fuel Cell Technologies Office essentially coordinates hydrogen activities across the whole Department of Energy. It's working to basically to bridge the gaps in technology, to unlock potential for clean hydrogen, to tackle hard to decarbonize sectors in the U.S. economy, to create job opportunities, to lift up communities, and to help the U.S. meet the climate goals of President Joe Biden. They also have something called the DOE Hydrogen Shot. Basically, the U.S. is working through the Department of Energy offices and the national laboratories and are engaging with stakeholders across the country. And their goal is to achieve 80% reduction in the cost of clean hydrogen within this decade. In other words, before the end of this decade, they want to produce hydrogen at the cost of 1 kilogram, $1 per kilogram in 1 decade, which is what you will see here at the bottom of this screen. On June 7th, the Department of Energy Secretary launched the Hydrogen Energy Earthshot, and their goal is $1 per 1 kilogram in 1 decade. Now, the National Renewable Energy Laboratory performed a study where they assessed, this is regarding the medium and heavy duty vehicles. They did a study on the so-called cost of ownership, the TCO, total cost of ownership of medium and heavy duty vehicles. They did the study actually including not just hydrogen, but also including all other conventional fuels like diesel and others. And the medium and heavy duty vehicles currently account for 24% of the greenhouse emissions from the transportation sector in the United States. Therefore, this is really, if we're going to decarbonize the US economy, we're going to have to work on the medium and heavy duty vehicles because it's almost a quarter of the greenhouse gas emissions. Now, these vehicles, for good or bad, they actually are heavier, they're used more heavily than personal cars. So on average, you expect the so-called commercial Class 8 tractors to travel over 100,000 miles per year. The commercial vehicles are extremely heavy. They can range from 14,000 pounds for the so-called Class 4 delivery vehicles to up to 80,000 pounds for the Class 8 delivery vehicles or tractors. So therefore, given this wide range of performance requirements across the medium and heavy duty vehicles of different classes and vocations, the decarbonization effort is going to be very difficult and is going to require a portfolio of clean technologies, at least for the near future. The study also described the total cost of ownership of Class 4 and 8 trucks powered by diesel and natural gas and batteries and hybrid batteries and diesel systems, and of course, using hydrogen and fuel cells. They made a prediction of what the technology is going to look like in 2025 and in 2050 when they did this study. The analysis that they performed was involving stakeholders everywhere, and is really considered the first account to calculate the indirect cost of what they call powertrains, in order to basically provide this information on the different market segments, so that we know how much money we're really dealing with in terms of in this particular part of the transportation sector. So I'm going to stop here. I think this is probably a good stopping point. I have many other slides I can talk to you about, but for now, this would be my presentations, and then we'll hopefully answer your questions at some point.
Thank you, Dr. Sherif. You've clearly given us a snapshot into what the current state of hydrogen energy in the United States, and also shared perspective in terms of how hydrogen is being approached for medium duty and heavy duty vehicles in the United States. I would now like to invite Professor L.M. Das, Dr. L.M. Das, for your initial comments, sir, and your quick presentation.
Good afternoon, everybody. I'll be talking about hydrogen, and I'll be talking about the application of hydrogen. Hydrogen is a fuel which is known to us for many years. Next slide, please. Next slide. It's not a radically new concept. No, the other slide, please. It's not a radically new concept. As you know, these famous scientific fiction writer, French writer, Jules Verne, had also thought of hydrogen about 200 years, more than 150 years ago, when he thought it from the energy crisis or the fuel starvation point of view. In one of his novels, Mysterious Island, he gives a very lifeful picture that a group of people are going in the ship. Suddenly to somebody, it appears that there is no fuel to propel the ship further. What you do? There's another person in the ship, he says, let us derive some power, some energy out of this vast mass of water and propel the ship further. So that means the visionary scientist had thought of hydrogen as a fuel from the energy crisis or the fuel starvation point of view. The entire dimension of the problem has taken a new turn right now because of the environmental degradation. You know, it is usually said, we have not inherited this planet from our ancestors, we have taken it on loan from our future generations. So it is our moral duty to hand over a livable planet to the next generation. And here comes the environmental degradation. George Bush, when was the president of the United States, declared hydrogen as the freedom fuel. Freedom in the sense of freedom from energy crisis and freedom from the monopoly of the oil producing countries. Next slide, please. As you know, right now, there is a unprecedented global shift towards decarbonization, primarily because of the fact that although if you are aware of the phenomena of, a man in the street knows what is global warming, what is greenhouse gas emission, how the ice cap is melting in the polar region, all these things are known to a common man in the street. So it is very important that hydrogen receives the attention it deserves. There have been many ups and downs. You know, hydrogen has been tried out several times. Even during the World War days, Germans have tried hydrogen very rigorously, even if they went up to the technology of hydrogen injected engine, which are destroyed in the bombing. But right now, many countries they have developed their goal-oriented, mission-oriented, time-bound plans for hydrogen, what to achieve by what point of time. There have been many joint programs between several countries on different aspects of hydrogen, and integrated hydrogen systems consist of production, storage, utilization, and all that. And all these things are being tried out. I think these are some common aspects into which I'll not spend much time. The next slide, please. India's hydrogen program, you know, India thought of hydrogen much before George Bush talked of the freedom fuel. In 1982, Department of Energy Sources, which was a part of the Ministry of Science and Technology, had got the hydrogen program. And they had given a project to IIT Delhi, that was the Department of Non-Conventional Energy Sources, in 1982, in which we tried on some engines initially. Subsequently, Department of Energy was graduated with a full-fledged industry in this country, Ministry of Non-Conventional Energy Sources, a unique ministry in the entire world. And they put a lot of emphasis on hydrogen energy. And the roadmap was prepared in which there are people from the oil industries, from the automobile industries, from the academia and the government. Mr. Ratan Tata was involved in the preparation of this map. And a very ambitious project was given to hydrogen as the idea of hydrogen being used in the auto sector. Then Ministry of Non-Conventional Energy Sources christened its name to Ministry of Renewable Energy, in which the work is being tried out with a renewed spirit of interest right now. Next slide, please. So the National Hydrogen Energy Roadmap, as I said to you, was prepared at 2003 to 2006. There were inputs from the oil industry, automobile industry, academic institutes, and the government. A very ambitious roadmap was prepared, which was approved in 2006. And then subsequently in 2020, they looked at the map again and revised it. So all these are available in the internet, and I think I need not go into details of it right now. What I'm trying to say that India has been a pioneering country in the hydrogen pursuits, and the objectives have been ascertained at different points of time, and the goals have been revised. And right now, you might have read in the newspaper today, the government has told the oil companies, Indian Oil, BPCL, HPCL, and GAIL to come forward with hydrogen production program by the end of this month. So this shows this surge of interest in this country to go to a environment-friendly atmosphere for the common man. Next slide, please. So this is a very ambitious goal. I remember in one of the World Hydrogen Energy Conference was I projected, there are lots of questions that how 1 million vehicles India could have by 2020. This is the roadmap that was prepared. It is always better to gaze at the stars. It is always better to have some apparently unreachable goal so that you put your efforts and whatever you achieve will be substantial. And this is what has happened in this country. Next slide, please. So I know the color spectrum of hydrogen is very important: gray, blue, green, and there are others like pink, yellow. All these are coming. These are all textual information. I'll not go into it. I just like to say there's a lot of emphasis on the green hydrogen. That means hydrogen. The production should be environmentally compatible also. In course of producing hydrogen, if it is not energy intensive and if you spend a lot of energy and if it is environmentally not compatible, that will not be taken for granted. So green hydrogen is the present thrust. Next slide, please. So this is the green hydrogen revolution. As I said, many countries have already done this. US has revised this program. European Union as a unity has gone and different countries are trying. Japan, Australia, South Korea, all these countries have been trying. In Indian Oil plans to use the wind power for the Mathura refinery. NTPC has got a very big plan, and the Advani and Ambani group have also. So what I'm trying to say that in India, the unique feature is right now is that both the government, the industry, the academic, and the common man, everybody is contributing significantly its might to the hydrogen energy program. Next slide, please. Next slide. Next slide, please. Greenhouse gas is something which is very important. I'll not go into details of it, and you can just see that India is quite high up in the list, third in the world in the global emission of greenhouse gases from the transport sector. That means transport sector is the main culprit, and emissions have to be certainly curtailed down from the transport sector, and hydrogen provides the answer. Next slide, please. So this is a study in India. You can see the carbon dioxide is just increasing, and it has been estimated to be so high in 2020. So we have to cut the carbon dioxide emissions from the transport sector. It is because it's on the Indian roads. And obviously hydrogen provides the answer. Next slide, please. Dr. T.N. Vajiroglu did a study in University of Miami, and he said how the hydrogen energy is building up, how the fossil fuel energy is diminishing and hydrogen is going up. This is a study which was carried out with lots of practical data and modeling. Next slide, please. Next slide. Hydrogen is the alchemy stream because you get it from water, and upon combustion, it gives out water. It can be derived literally from all sources. You can get it from solar energy, from wind energy, from water, and from geothermal, from biomass, everything literally. The technology are different, obviously. For the production of hydrogen, there is an infinite source potential with an ability to provide almost zero emission. So this is a broad investigation of engine strategy, which is very important because the transport sector, the main culprit is the internal combustion engine right now. And internal combustion engines, all of you are aware, are of two types: spark ignition and combustion ignition. So there are several types of studies that has to make the performance, the emission, the combustion, the lubrication studies, the endurance test. All these aspects are to be very rigorously investigated before building up a engine for transport sector. Next slide, please. Backfire has been the Achilles heel for hydrogen engine. Because of the low ignition energy and high flame speed, Sometimes the hydrogen, if there is a hotspot, there is a concentrated source of thermal energy, it inadvertently acts like a spark plug, and the flame propagates back into the manifold. And that is precisely why hydrogen energy research could not be continued and got restricted to laboratory curiosity only. And all these positive features of hydrogen were clouded by the single culprit backfire. But now backfire has been very thoroughly investigated, and the steps to be adopted to get rid of backfire has also been identified. Next slide, please. We in IIT Delhi carried out a long-term work, and this particular, the injection of fuel, the introduction of fuel into the hydrogen engine or hydrogen vehicle is the crux of technology. You cannot have a carbureted system because backfire will not be eliminated by that. As you know, hydrogen flame is invisible, and it has got a very high flame speed, and it needs minimum ignition energy. So once the flame propagates back into the manifold, then it ends up in explosion. University of Oklahoma, at one point of time, some projects given by Department of Energy, United States were discontinued because they are not able to identify the cause of backfire. In IIT Delhi, we carried out a series. This particular table reflects the work of several years in which the optimization of hydrogen into the how to introduce hydrogen into the engine was finally optimized, and timed manifold injection was important because you introduce hydrogen at a point into the manifold when it doesn't come in contact with air. I think these technological aspects are very well given in the literature right now. Next slide. Hydrogen is flammable over a very wide range. This is a very important drawing. It's a very important figure from the book on combustion by Lewis and Vernal Bay, which is a very famous book. From that, it has been so. Even though hydrogen is flammable over a wide range, but it has to be a very narrow window is suitable for the engine application, which is shown here. Next slide, please. So these are the different configurations that were built up in IIT Delhi. The first figure shows that we had a research engine in which can run on petrol as well as diesel. That means there was a spark plug as well as diesel injection pump. So we used the diesel injection pump, and the injector was the actuating mechanism, and hydrogen was injected into the manifold. Then this second figure, the second generation figure, the middle one is the CAM actuated injection system, which was done because all engines will not be available with the facility of running petrol and diesel together. That is why the injection system actuation mechanism was changed to CAM actuated. And subsequently, technology was transferred to a utility engine on third figure, where you can run any engine hydro. The injection system was a very rigorous technical exercise, and we found out a solenoid actuated, electronically controlled injection system is the ideal for hydrogen engine. You can see below the gensets, the bulbs are running, the insets are tried also. The last two figures are diesel engine. It's almost axiomatic that a good fuel for petrol engine is a bad fuel for diesel engine because of the radically different combustion characteristics. Hydrogen is a good fuel for the spark ignition engine, but it is not the ideal fuel for the diesel engine because auto ignition temperature of hydrogen is about 576 degrees centigrade. In Cornell University, they have tried a compression ratio of to 29, and they were not able to achieve compression ignition. But a dual fuel engine, which is a very interesting technology for gradually gradually introducing hydrogen, you can have hydrogen and diesel together. The last two figures are those which have been developed in IIT Delhi. The middle one is a multi-cylinder Ashok Leyland engine, and the other is a genset. Next slide, please. This is a very interesting data of IIT Delhi, which is reported very much. Oxides of nitrogen is the only pollutant of concern in hydrogen. There is no carbon monoxide, no carbon dioxide, no hydrocarbons, no aldehyde, no ketones, no sulfur dioxide, no particulate, nothing. It's only oxides of nitrogen. And oxides of nitrogen, if you know, kinetics of Knox formation is dependent on temperature, the residence time. And if you can look at the curve, this is very different from the typical bell-shaped curve, which is obtained from petrol and diesel engines, because hydrogen can run at a very low equivalence ratio of 2.23, as you have found out in a research engine, in sharp contrast to about 0.6 for a regular spark ignition running on petrol. That means you almost achieve zero emission features if an optimized hydrogen injection system is properly developed. Next slide, please. Again, the hydrogen embraces the benefit of both petrol engine and diesel engine. It can go up to the compression ratio of a diesel engine. And you can see here that we have been able to achieve a efficiency of close to 44% thermal efficiency, which is unthinkable for any spark ignition engine configuration running with petrol. This is possible because you can have unthrottled operation, so there is no pumping loss, and you can adopt a higher compression ratio to achieve this. Next slide, please. This is the pressure crank angle diagram, which is a combustion, which indicates that the combustion is very smooth. There is no perturbation in the diagram, as you can see. Next slide. So as I say, diesel engines are not suitable for hydrogen to be used as a neat fuel. So dual fuel operation is ideal. Next slide, please. Next slide. Sorry, this is repeated, sorry. And safety is something, as you know, a known devil is better than an unknown angel. When you talk of safety, from many points of view, hydrogen is safer than gasoline. Professor Michael Swain of University of Miami got a project, multi-year project from Department of Energy, and carried out a lot of hydrogen engine activities. But hydrogen still couldn't get off because of the stigma attached to it. The hydrogen bomb and the Hindenburg disaster had attached such a stigma that if you talk of hydrogen to a man on the street, he looks at you with eyes wide open. So these are some of the experiments he did. As you see in the first figure, hydrogen glows very fast, but because of its radiation hazards from hydrogen are practically zero. And because of its diffusivity, it almost vanishes to incombustible proportion immediately. And you can see in the second figure, after 10 seconds, the petrol has eaten up the vehicle, whereas hydrogen engine is very safe. That means if properly handled, hydrogen could be safer than gasoline. Next slide, please. After all this work in the laboratory, it was decided that the technology must be transferred to the land. Next slide. At this point of time, Professor Vejiroglu, who happens to be the president of International Association of Hydroenergy and editor-in-chief of International Journal of Hydroenergy, happens to be, he's now retired, a professor of University of Miami. He visited India and he has a look. So he suggested, why don't we try to take this work into the field? So what we did, that luckily at that point of time, there was a committee made by Mr. Chidambaram, the other principal scientific advisor to Prime Minister. They call it Core Group on Automotive Research. In that one, I projected my ideas, and this caught the fascination of Dr. Pawan Goenka, and he suggested that IIT Delhi and Mahindra should take up a project where the application of hydrogen can be tried on the auto vehicles. So there was a proposal inviting projects from the UNIDO and IIT Delhi. We submitted the proposal. Luckily, it was accepted. And at that point of time, I had also gone to the United States and given a talk, and Air Products appreciated my idea. It was a very opportunistic moment, a very good moment when the industry and academia joined together. IIT Delhi, Mahindra and Air Products, all the three of us worked together from production to utilization of hydrogen. Next slide, please. So this This is the work that was carried out in the IIT Delhi laboratory to optimize all the parameters that could be ultimately translated to the engine running on road, to the vehicle running on road. Next slide, please. As you can see the fuel consumption. Hydrogen fuel consumption is substantially lower as compared to petrol. They're practically, much lesser, you can see from the graph here. Next slide, please. Similarly, oxides of nitrogen in these tubular engines, you can see this tall figure is for the petrol, whereas for the red marks that you can see, even some were not able to show the bar and we had to write the figure in ink. That means practically no NOx emissions. So it's a matter of deep satisfaction to express here that the three-wheeler of Mahindra and Mahindra, which was developed by the joint effort of IIT Delhi and the engine study and subsequently by Mahindra in the road test, could develop a system which had practically no emissions. Next slide, please. So these are the, in 12th January, the three-wheelers were inaugurated. People from Mahindra, people from Air Products, IIT Delhi, and ITPO, Pragati Maidan, where these vehicles are running, all of them were present. It was inaugurated. It had a long, it came out in CNN, IBN, European Union, and many other places, Belgium. On the right side, Air Product has airlifted one of their units to Pragati Maidan, and vehicle is getting filled up. So I just wanted you to have a glimpse of these photographs. Next slide, please. Then subsequently, we are suggested by Ministry of New and Renewable Energy to graduate this technology to a minibus development. Again, in joint collaboration of IIT Delhi and Mahindra. We did that. Again, the engine was installed in IIT Delhi and was optimized. Next slide, please. Next slide. It was installed in that engine, and we adopted several things here, like exhaust gas recirculation, as we did. Then we had some SCR catalytic converter. That means post-combustion control of oxides from nitrogen were also widely tested. Next slide, please. So obviously, the way forward, I feel, now everybody is aware of hydrogen. There should be lots of, the safety features have to be further propagated to the field. There should be many workshops indicating the people, and I think a very optimal integration of academy, industry, government, all these things should be there so that hydrogen can move forward. Next slide, please. So this is the best way to have it, because safety aspect has to be properly understood by the users. Then the workshops should be conducted, and there should be a cluster model in which there should be some facilities of going from production to utilization. Next slide, please. And as I say, it is high time to go for hydrogen. And in all research, I often quote Robert Frost, who says, "Miles to go before I sleep." Thank you so much.
Thank you, Professor Das, for that very, very detailed, perspective on hydrogen as a technology, and also, you're talking about the unprecedented global shift towards decarbonization and how hydrogen can play a role. I would quickly move now to Mr. Arikapudi Suresh from Tata Motors. Mr. Suresh, if I could invite you for your initial comments on the subject before we move to the Q&A session.
Yeah, sure, Dev. Thanks for the opportunity. Basically, I think
please switch on your camera as well, please.
I'm not getting a self view.
Okay.
Maybe
I can see you now.
Yeah. You can see it. Okay, fine. I'm not able to see my view. So, okay, fine. Coming to the main part, as Dr. Professor Das has said, the journey of the national hydrogen point of view, it was almost started in 1982, and the real speed or the emphasis came in during 2003, when there was a National Hydrogen Energy Board was created, and it was a clear focus study was planned to identify the generation part, and then consumption and the application, and then safety aspect point of view, and then also promote this hydrogen consumption and application side both on the IC engine and the fuel cell. So when we look at some group started working IC engine, so Professor Das was part of the team, and Tata Motors took a mixed approach, both on IC and fuel cell in the initial, and then primarily focused on the fuel cell going forward. So in this journey, we have built few buses along with the collaboration of DSR, ISRO, and ISC and IOCL. And during this journey, we learned that it is not only technology which is going to stop for the hydrogen adoption point, but it's more of the complete ecosystem has to be developed. So we can imagine getting a pure quality of hydrogen for PEM application point of view. When we started searching, we found that chloroalkali plants is one of the big sources sitting in the country. And this itself as standalone can support 10,000 buses of operation per day. So that's a quantity of hydrogen which they generate as a byproduct. And we can use it for a mobility purpose point of view. Then it's one other part as with the filling stations point of view. If you look at the dispensing stations, there are two captive plants, one in NIC and other, I think it's in the IOCL point of view. But there is no public charging stations, public dispensing stations are not there actually. So one of the big gap is that, so then we have to find a way how to fill the hydrogen on the vehicle to mobilize them and then operate them. That was one of the bigger challenges which we had to overcome. And then the safety approval. The whole of the chain of the approval process is not established when we are building the bus. Then we have to get into ARI, talk to different authorities, get a permissions, and then get into creating this whole of the ecosystem for certification of the buses point of view. And next as well as the testing of the whole thing. So testing of the vehicles and as well as the aggregates. That is also is not there right now. So the whole of the momentum has to take place to establish the whole of this facilities also has to be there. So, and to support all this journey, you need a manpower. Amount of manpower, there are good expertise are there, but there are few in numbers. So this volume of the manpower has to be expanded. Similarly, today, if you look at the battery growth, a lot of industries are facing the shortage of experts in the battery. A similar thing will happen when over a period of time when we want to go for a mass scale of the fuel cell. So that is one of the things which has to be taken into consideration right now, and then expand the whole of the expertise development, and as well as creating a volume of people who can support this whole journey is all about. So when we look at the overall point of view, safety is one of the things which is not fully established. So that we need to have a lot of efforts in creating it. And I can see a lot of momentum taken for the last 1 year by National Hydrogen Mission, as well as a lot of PSU companies like IOCL, NTPC are issuing the tenders and EOIs for the pilot fleet. So when we see this journey, there is momentum is gaining up. I feel that all the aggregates and the OEMs definitely will be able to come on board and support this journey going forward. Thanks for the introduction.
Thank you, Mr. Suresh, for the initial comments. Now, when we look at Tata Motors, I mean, it has said that it is working towards setting up a target to be carbon neutral. And as a part of its overall plans, there is focus on battery electric vehicles, as well as hydrogen fuel cell technologies, right? As you move towards green mobility. Now, talk to us about the company's preparedness and, when it comes to hydrogen run vehicles.
Sorry, missed the last one.
Yeah, I mean, the question is for you, Mr. Suresh. I wanted to understand, I mean, with your focus on greener mobility to setting your target to be carbon neutral in the future, how is the company preparing to, with regards to hydrogen run vehicles?
So presently, it's more of if you look at the whole journey, everyone has started working in a small scale. Over a period of time, we have to see how the momentum gains in the overall national policy level, and then based on that, people will be putting more resources on the plan point of view. So today, it is more of a nascent phase. We are waiting to the whole of the policy triggered from the government to enable the whole of the journey right now.
Okay. All right. So policy clearly will play a role. Dr. Sherif, I'll come to you now. Mr. Suresh raised a few important points in terms of, he talked about safety being, being absolutely necessary to sort of ensure that hydrogen is established. Now, if you look at the transition that the world is going through towards hydrogen, now what are some of the biggest gaps when it comes to implementing hydrogen as an alternate fuel option?
I think, as Professor Das has indicated, there is a perception, and he called it the stigma, that hydrogen is stigmatized because people perceive it to be unsafe. The truth of the matter, however, is that as he indicated, the study that Professor Michael Swain at the University of Miami conducted back in the late 1980s and early 1990s, and I happened to have been a colleague of the Professor Swain at the time because that's where I was working, and the hydrogen is the lightest element. Therefore, when you have a hydrogen leak, it actually goes up. If you're using hydrogen in the kitchen, if you have an opening in the kitchen hood, it escapes the house. If you're in a car and you have a hydrogen leak, it goes up, as opposed to gasoline and other heavier fuels that actually, as he demonstrated, would burn the car. It will continue to linger. There was an accident in a muffler shop in Miami back many years ago, where propane was used, and the propane leaked. And because propane is very heavy, it lingered and stayed at the lower levels. And when the person came in the next day and turned the light switch on, the spark caused the muffler shop to explode. Now, all of that would not have happened had that been hydrogen. And all you have to do is just have a place in the ceiling where hydrogen would escape. So the perception, I think part of the problem that we're facing is that there's a lot of bad publicity from previous years of perhaps misunderstood why an accident happened. I'm talking about the famous accident that all of us know. So this is part of the problem. There are many other issues. Part of it is that the status quo has been very good for many of us. The price of oil is cheap, and people don't really worry about what they pay for lung diseases and other problems that cause acid rain and many other things that happen because of fossil fuels. If you factor all of those things into account, as Professor Veziroglu would tell you, the cost of fossil fuels would be probably the highest cost of any fuel. So I think all of that is part of the education that we all need to be engaging in. Professor Das has done a good amount of that. Professor Veziroglu has done a good amount of that. Many of us are talking to people and letting them know. Of course, things are not bad the way, compared to what things were 30 years ago. I'm very optimistic, and there is now the researchers are all over the map. The International Journal of Hydrogen Energy is a good example, where they are publishing 60 issues every year, and typical issues are sometimes 1,500 pages, 2,000 pages, and researchers are coming from all over the globe. So there is a lot of research being done. The US, which is a very important player in this, has taken great interest in it. Back in the time when George W. Bush became president, and he had a push towards hydrogen, and then things faded away for a long while, and then things are coming back. But they're coming back in my opinion, was a vengeance. They're coming back very strongly. So I think we just need to keep pushing. To answer your question, we just need to keep pushing and educating people, and then the researchers are busy. There's thousands of researchers working on hydrogen energy as we speak. So the future is looking good, but in the end, I think economics is going to be the deciding factor. If we can get $1 per kilogram, I think it's going to be the winner, at least one of the major winners.
Sure, Dr. Sherif. Dr. Das, would you concur with Dr. Sherif in terms of, if you look at what India is doing currently, the whole new hydrogen mission that was announced, do you think India is, matching the world step by step as far as hydrogen research and development is concerned?
Absolutely. I fully agree with Professor Sherif, whatever he said. And India, I think, is very critically analyzing and putting a lot of stress on hydrogen. And obviously, India has already identified which aspects of hydrogen energy have to be really tackled and tamed so that the hydrogen energy moves at a much faster rate and has an accelerated implementation in the energy sector.
Okay, so while we move towards ensuring that hydrogen could possibly be India's energy of the future, what are some of the building blocks that we must focus on, Dr. Das?
See, as you know, in India, as you have seen in past, the schemes sometimes we introduce a little late, but when you implement it, we do it in a very rapid scale. There are many examples in the country, starting from the, as far as the vehicular emission is concerned, starting from the simple, auto vehicle, the Euro standards, and say lubricating oil, CNG, hydrogen. We have several programs in this country. And India is a country where the unity in diversity is applicable not only to language and religion, but also to the technology. So obviously, what is important that if you remember, we had the biofuel policy report and with emphasis on biodiesel and bioethanol long time back. But because of the specific reasons, specific geographical region, the entire problem took a different turn. Similarly, in hydrogen, the problem is very different. It could be universally adopted, provided the production source become economically viable. That is the main thing. The utilization aspect has been very thoroughly studied in this country. And as you see, utilization of hydrogen in the engines, gen sets, pump sets, and fuel cell buses, all these India is quite far ahead. So an integrated program should be economically viable, and the main thrust should be on the production of hydrogen, in which I think Government of India is putting a lot of stress. Today in the newspaper, I read that Government of India has suggested the oil and GAIL, IOC, HPCL, BPCL, and GAIL to come out with a program by the end of this month. So I think we're on the right track, and the production aspect should be economically viable.
All right. All right. At this point, Dr. Sherif, I'm going to take a question from one of our delegates. So Saurav Mohan Saxena is a founder of AHODS Technologies. He wants to know, in perspective of the existing huge IC investments per vehicle park and further Bharat or Euro 7 norms, patented technologies like AHODS, which is hydrogen on demand systems, by startups using hydrogen along with gasoline fuel in IC before the fuel cells to cut fuel and emissions. So what are your views and inputs on this?
I'm not sure I follow the
okay.
thought. Would you summarize one more time?
All right. So essentially what he's trying to understand is technologies like hydrogen on demand systems, right, by startups. So, what is the kind of opportunities and how can they really look at the future? He wanted your views and inputs on that.
I'm not familiar with the hydrogen on demand concept. I don't think I can really comment.
All
Maybe
right.
Professor Das can have a better answer on that.
Professor Das?
Yeah, I think it should be very clearly understood that fuel cell and IC engines are not mutually conflicting. They are just two different routes to the same destination. I mean, in this particular case, we cannot blindly adopt what is being done in United States and other countries. India, I think, as you said, he has started internal combustion engines, hydrogen on demand. I think this is a very commendable effort at this point of time because the technology is mature in this country, and internal combustion engines, in my opinion, are going to survive in this country for a pretty long period. Fuel cells obviously are the ultimate, but there are some constraints in the fuel cell. Purity of hydrogen has to be 99.99%, whereas internal combustion engine tolerates the impurity. So for a pragmatic implementation for a country like India with diverse social strata, I think the effort he's putting on internal combustion engines is worth trying that. But obviously the ends will be towards the fuel cell at the end of the day.
Okay, so I have another question coming from Siddharth Bami. He wants to know, given so many alternative fuels options are available currently, how can we, without a full end-to-end life cycle cost analysis, adopt a new technology? So he's asking about how is it possible to adopt new technologies without doing an end-to-end life cycle cost analysis, more so when there is already a significant installed capacity available or in place for traditional fuels.
I can probably take a stab
Yes.
at that. Well, I just told you about the NREL study, the National Renewable Energy Laboratory. They did a study, and it's available. You can Google it. There, you can download the whole report. They've done actually a total cost of ownership concept, where they, from the time you buy the vehicle till the time you dispense with it, how much cost will it be that you're going to have to pay? And they've done that for all types of fuels, conventional fuels, diesel, for example, as well as hydrogen. So this is probably the first, at least to the best of my knowledge, the first study that has ever been done where it talks about the total cost of ownership and they focused on the medium and heavy duty vehicles. I told you that the medium and heavy duty vehicles, they produce 24% of the greenhouse gases in the United States. So it is a good segment of the transportation sector that needs to be addressed. So you're right. We cannot make decisions until we know exactly how much the cost would be from inception until death. But there is a study that has been done on the medium to heavy duty vehicles that we need to do more in other sectors of the economy. So more of those should be coming, and I have no doubt that they will be forthcoming soon.
Thank you, Dr. Sherif. Mr. Suresh, I'll come to you with this question from Mr. Sumit Chakraborty. He wants to know that some comparison of hydrogen versus electric. He wants to know if you have any comparison between hydrogen and EVs. What should be the strategy? Focus on EVs or hydrogen? So that's his question.
Yeah, I mean, if you look at typically both are required for achieving the net zero target point of view. So battery point of view, it has some disadvantage of continuing for a long duration of operation or a long running miles per trip point of view. So basically, if you look at the truck and the cars point of view, there is always a segment beyond 400 kilometers, which definitely cannot be addressed very well by the battery point of view due to the charging point of view or because of weight penalty point of view. Those segments where as a clear reach is there for the fuel cell, and a high tonnage application also, it's definitely a clear reach is for fuel cell. So it is in a short form, both are going to coexist, and it will have a different clear demarcation will be there in the both the segments of operations point of view.
Okay, from when we look at the future, do you think that introduction of, let's say, hydrogen blended CNG could be a potential first step in the Indian context in a journey towards this hydrogen economy?
I can take a stab. I'm sorry. No, go ahead.
Yes, Dr. Sherif, please go ahead.
No, it's okay.
I'll come to Mr. Suresh.
Okay. I was going to say that we don't need to do blended compressed natural gas and hydrogen because, to be quite honest with you, the technology to build internal combustion engines that operate fully on hydrogen has been known since the late 1960s and 1970s. My good friend, Professor Michael Swain, built 19 hydrogen prototype engines for Ford Motor Companies and for other Japanese manufacturers as well. The technology is known, and it really is a matter of political will. If we want to make cars that run on liquid hydrogen or gaseous hydrogen, we can. We know how to do it, and we know how to perfect the internal combustion engine to produce the perfect power and the perfect efficiency. So I don't think we need to go to blended hydrogen and compressed natural gas. Natural gas is a fossil fuel. Let us not lose track of that fact. It produces methane, and that is the most egregious greenhouse gas. So I just wanted to make that point loud and clear on that. Thank you.
Sure. Mr. Suresh, your inputs on that?
Yeah, so if you look at the overall point of view, this blending part is already notified on the Indian government side also. So basically, this is meant to trigger the hydrogen generation aspect point. That's how the thought process was, what I understood from the teams. So this is just to create the momentum over there where the hydrogen generation and the distributions what you call establishment can be created, and then we can create slowly more towards the hydrogen economy point of view. It's like a trigger point. That's the idea behind it.
Okay. Okay. I mean, we've run out of time, but I'll take one further question from one of our delegates, Sanjay Patil, who wants to know if any specific coatings are required for hydrogen fuel cell vehicles from a thermal management point of view. Anyone can take that question. Mr. Suresh?
Yeah, one for the fuel cell point of view, I can answer it. Basically, if you look at the thermal system, typically there is these temperature bands are close to around 80, 85 is the max temperature, which we say in the operation of the fuel cell system. So to manage this low temperature heat rejection in the Indian hot conditions point of view, that's one of the bigger challenges. So that's where one of the core, we have to put a more efforts to create a system where we can dissipate the heat at a lower delta T. That's one of the big area which can be challenging and which can be worked about for a solution.
Okay. All right. Okay. So what I'll do is, since we have run out of time, I'll start with you, Dr. Sherif, your final comments on the way forward. What are the key takeaways for the future?
Well, I think the way forward has to be multidimensional. It has to be multifaceted. I think we need to do all options are on the table for now. I think we need to continue with the all options concept, and then we let the different technologies compete with each other, and then pick the best, the most economical technology. So that there may not be one technology that would be the ultimate supreme winner. There is batteries now. There is electric vehicles. I'm all for that. That doesn't necessarily mean that we have to slack on doing other things. And maybe one day we will have both electric vehicles and hydrogen vehicles on the road.
Right. Thank you, Dr. Sherif. You know, you're talking about taking a technology agnostic approach, and there is certainly a potential for the market to accept different forms of fuel. Dr. Das, your final comments on the way forward. What are the key takeaways?
Yeah, as you see, in our country, I mean, depending upon the particular wealth in a particular region, we can have different, we have a program from ethanol, we have a program for methanol, there's a program from DME, there's a program from electric vehicles, the program from hydrogen. I think all these things could simultaneously move in our country. And as far as hydrogen is concerned, there should be an integrated facilities where you can try, as similar, say, from well to wheel, starting from the production to transport to utilization, storage, all aspects could be studied so that we identify which technology has to be further critically looked into and amplified. And I also feel hydrogen CNG phase is over in this country because the engine technology is mature, and that was just a bridge. It was a transition phase, and that phase is over in this country. And it may not be a quantum jump now to hydrogen, but gradually, depending this facility, and what is more important is an optimal integration of the industry, oil industry, automobile industry, academia, government, all aiming at the same goal.
Thank you. Thank you, Dr. Das. Mr. Suresh, your final comments.
Yeah, yeah. I also totally agree that everything is going to coexist point of view. So because everything has to evolve and then naturally based on the market conditions as well as the cost benefit point of view, naturally few things will die off and then few things will sustain over a period of time. So at this point of time, we don't have to re-emphasize on a specific technology. It can naturally migrate or evolve over a period of time, and then it will converge to its final destination point of view. One thing is, any case, we need to create a good amount of manpower, resources, and infrastructure for all the evaluation of all the type of technology. That is the primary focus which we need to have it in India, so that be able to create a complete ecosystem for development of all technology.
Fantastic. So gentlemen, we have, like I said, we've run out of time, but I truly appreciate, your views, your perspectives, sharing your knowledge with our participants today, Dr. Sherif, Dr. Das, Mr. Suresh. Appreciate your time. Thank you. Thank you very much. And clearly, hydrogen has a tremendous potential, like you said, but we must also look at it from the perspective of all the other options that are there in the market. And like you said, there is all of that could coexist while we go towards carbon neutrality in the country and the world. Thank you. Thank you very much, gentlemen. I appreciate your time.